My name is Arsalan Javed, and I'm a recent graduate of electrical engineering from NUST. And currently I'm working on a project which we like to call TAME, and it stands for Tremor Acquisition. I'll tell you a little bit by starting with tremors. You see, tremors is a disorder which causes people to lose control of their bodies, and especially their hands, because of uncontrollable shaking. So what this does is that it makes them dependent on people, somebody other than themselves, to do even the most basic tasks like eating, drinking, writing, and sometimes even dressing themselves. So there is currently no proper solution or effective remedy for this particular disorder or disease. So that's where we came in with our solution, which we like to call TAME. So TAME is basically a wearable device. Think of it like a sleeve. So it has the ability to detect where the tremor is moving the arm and then cancel it with an opposite motion, which is generated by electrical stimulation. So what that does is that it essentially stabilizes the hand and gives the control back to the patient, and thus they essentially regain their independence. There were a number of factors. We're three people in this project, and each of us came with a different background. So for me personally, we actually saw our seniors who did something of a similar project, but that was only for the diagnosis of the type of tremors, which is a great project in itself, but we wanted to take it one step further. So we wanted to actually find a solution and stop the tremor at once. And for that, what we did was, the main point of inspiration was, we saw a TED Talk. It was, I believe it was called a human-to-human interface. So the speaker, what he did is that he brought two people from the crowd. One of them was a girl and one was a boy. And he connected both of their arms to a machine. So when the girl moved her arm, what it did was the boy, involuntarily moved his arm as well. So we took this concept, we saw what kind of technology was going on behind there, and we started researching on it. And we said that if one person can generate a movement in another person, why not that same person generate a movement in himself, but in the opposite direction? And that's where we started our research, and that's when we tried to look up literature on what could possibly be done in this particular situation. And that's when we started iterating different circuits, different solutions, different models for algorithms, and we eventually came to our prototype and started testing on patients. The thing is that the whole point that at least we believe about being engineers is that we should actually be able to use our knowledge to find solutions. We should be able to take all of that technical stuff and put it into a viable solution that actually solves a problem in society. So the whole point about impact is that we're all interested in the biomedical domain, because we believe that if we want to create an impact at the most personal level, it is by solving the problems which affect human beings due to circumstances which were not necessarily under their control, like diseases or birth defects. So the whole point of impact over here is that it's directly affecting the lives of people. So that's the whole thought process behind our motivation. On the road, first of all, we want to give closure to this particular project. It is difficult considering that it's a biomedical device. There are lots of regulations, a lot of authorities that it has to be passed through. So currently we are working on finding a way around all these technicalities so that we can actually take our solution from the lab and give it to the people who actually need it the most. So that's, you can say, the ultimate goal of this particular project.